All right, so in this particular group of videos, we're going to be talking about parallel lines. Now, we discussed parallel lines before because when we were graphing lines on a coordinate plane, we had to use the slope and the y-intercept, and we know that they're parallel because they have the same slope. But notice these parallel lines, of course, the ones that are going the same direction, that have the same slope, there's no graph. They're just existing in free space. So the way that we signify that they're parallel are with these two little red triangles I put there. So they're right here and here. Okay. So those are how we signify that these lines are parallel, meaning they're going to go, they have the same slope, they'll never intersect for as long as they travel, and lines go on forever. So just wanted to remind us of that. Now, I notice how, because they're parallel, and I drew a line through there. Okay, so a line goes through the parallel lines known as a transversal. Okay, so a transversal. And the transversal is basically it travels or transverses the parallel lines, and it creates angles. And you'll notice how I labeled 1, 2, 3, 4, 5, 6, 7, 8. Now, because those two lines are parallel and they're cut by a transversal, there's certain properties about these angles that that will make them either congruent or something else. And so we're going to go ahead and explain those to you right now. So the first kind of angle we're going to talk about are called vertical angles. Okay? And vertical angles are always congruent. Okay? And so here's what I mean by vertical angles. Okay? I want you to take a look here at angles 1 and angles 3. Okay, so look at angles 1 and 3 there on the graph. You'll notice that there's angle 1, and here's angle 3. Notice how I like to think of it as mountain peaks. Okay, so let me back up real quick. So you notice that, see how the two lines make like kind of a peak at angle 1? Okay, and vertical reminds me of how tall something is, and mountains are really tall. So the two lines come together, and they form a peak, just like how the two lines at angle 3 come together and make a peak. So when the two peaks touch each other, that means they're vertical angles. And those are congruent, meaning they're the same measure. So, and then that would also mean angles 2 and angle 4 are vertical angles because, again, the two mountains kind of touch each other. So the angles down below, 5, 6, 7, and 8, that would mean 5 and 7 are vertical angles, and 6 and 8 are vertical angles. And that's because, again, the way I think about it is there are two lines that cross each other, and the angles on the opposite sides are congruent or the same measure. So vertical angles is one of the things we need to know. The next thing we're going to know, there we go. Okay, let's label all those again. The next one we're going to talk about is corresponding angles. Okay, and corresponding angles, just like vertical angles, are always congruent. But here's the way I like to describe corresponding angles. So we have angles, for example, 1 and 5. Now, notice how 1 and 5, I'll put green dots there. Notice how in the group of 4, 1, 2, 3, and 4, in the group of 4 angles right there, angle 1 is in the top left side. So angle 1 is in the top left of all 4 of those angles. Look at angle 5. Angle 5 is also in the top left of all those angles around it. So that's why they're corresponding, because they're in the same position, just obviously in a different group. So the same spot, the top left, just in a different group. So that would mean angles 4 and 8 are corresponding because they're both on the bottom left. So 4 and 8 are corresponding, and that means they're congruent or the same measure. And 2 and 6 are corresponding because they're both in the top right, and that would mean 3 and 7 are also corresponding because they're on the bottom right. So those are corresponding angles because they're in the same spot, just within a different group of angles. So that's what corresponding angles are. And the last big one we're going to talk about is, I'll draw those parallel lines again, is going to be alternate interior angles. And alternate interior angles are also always congruent. And here's what alternate means. Alternate means in baseball or soccer, you would say the substitute or the other player or the basically what we're getting to in math is the other side, okay? And that doesn't really help unless you know what interior means. Interior means inside. So when we talk about inside, we're talking about inside the parallel lines right here. So we're talking inside the parallel lines. So the angles inside the parallel lines are 4, 3, 5, and 6, right? Because they're inside the parallel lines. That's what interior means. Okay? And now alternate, now this really helps. So they're the angles on one side and then the other angles on the other side. So the first pair of alternate interior angles are 3 and 5. Notice how they're both inside the parallel lines, but 3 is on the right, 5 is on the left. So 3 and 5. And the other pair would be 4 and 6, because you'll notice 4 is on the left, 6 is on the right, and they're inside the lines. So that is alternate interior angles. And so those are the three major theorems we're going to use when we talk about angles and congruence and parallel lines. And you'll need this info so we can do our homework.